So some of you are already working with stimuli and presenting stimuli and so on, but let me just give you sort of a 5-minute overview of what actually happens when you do this kind of stuff, right? So if you're not using ePrime or presentation or one of those tools, you'd usually end up using something like toolbox or Cogent or one of those other toolboxes in MATLAB or some other language. And when you use them, all of a sudden, rather than just saying, oh, put up an image or a little movie for 5 seconds, all of a sudden you become responsible for the lower level stuff of presenting the stimuli, right? So you're kind of like nearly having to program a computer game to the point where you decide what's the next thing that's going to come up on the computer screen, what's going to happen when somebody presses a button or the mouse, and so on and so forth, okay? So at the heart of all of those tools, or this idea of these toolboxes, is they mostly now use something called OpenGL, which is a sort of a language or specification for displaying computer graphics. Actually, you're probably mostly thinking about 3D computer games and sort of flying through virtual worlds. But the library that does this actually is very good at drawing other things as well. So, you know, like if you're just interested in drawing dots or squares or something like that, it can do that very well. So there's this language which has been implemented for all of the operating systems that allows you to open up a screen, like make everything go black, draw simple geometric shapes like dots and circles and lines, various other kinds of things to do with the screen. And then one thing that's very common is you don't actually want to build a picture of a cat out of little rectangles. You want to load in an image from a file and display that. Okay, so that's a slightly different operation, because for a square, you say, I want you to put a red square that starts bottom left to top right there, and the color needs to be there, and that's it. For the image, you actually probably have 100 by 100 pixels that you need to display. So there's some additional information that you need to do. And so the way that works is, there's on the computer, on the graphics card, that information gets sent to the graphics card, and then it ultimately gets sent to the screen, okay? And there's sort of a whole bunch of stuff happening in the meantime. Now the drawing model for OpenGL seems a little bit weird, okay? So what happens is, you decide that you want to draw something, you open something which is called a context for drawing into, and that makes space on the graphics card for you to draw stuff, and another space which is the place where things are that are currently displayed on the screen. Okay, so sort of frame buffer. When you are drawing, you're not actually drawing directly on the screen. Does anybody know why that's the case? That's what happens, exactly right, but do you know why? As a vision scientist, you might know, actually. Sorry, I made a gag on my coffee. Well, our eyes are too good, basically, right? So it takes some amount of time to tell the graphics card, draw a line here and do this. Often you have multiple objects that are overlapping, right? And it's not trivial to figure out which object you should draw first. So it might take a few milliseconds to do this whole thing. And if you actually do it in the place where it immediately updates to the screen, you get flickering and tearing and all sorts of weird artifacts because your eye is too quick, right, for the hardware. So the drawing model is slightly different, which is exactly what Christian was saying, which is that you actually draw, like in the back office, making this careful drawing, and when you're ready for prime time, you just switch over what's currently being shown to the drawing you've just carefully prepared over the last 16 milliseconds. Flipping these things is like instantaneous, okay? And then you have the stuff that you was just presented for a second, you have that space, and you can now do the drawing, and while you're doing that, you're displaying the same constant image all the time, okay? So actually, this is called the front buffer and the back buffer, and it allows you to do these things. But it basically means that when you're drawing something, you need to make space, you need to draw, and then when you're finished with drawing, you might think, oh, it should now show up on the screen. You need to do this extra step of swapping out these two places. And that's what screen flip, or this is what the flip basically is. Okay? So if you're just trying to display something that's constantly on the screen for a second or two, then you only do that once, and then the graphic card maintains this bit of the frame buffer for you automatically, and it just keeps on refreshing it at the screen refresh rate until you point it the other way, right? And then you flip around. If you want to make something move, what do you think you have to do? So you have to go back and forth, and every time you go back and forth, you're responsible for changing the location of the object, right? It's sort of old school. It's like you don't just say move over there. You go, oh, 16 milliseconds have elapsed. In order for something to move this quickly, I therefore have to move it by a tiny amount. And then the next time I go through the loop, I move it a little bit more, a little bit more, a little bit more. So you become responsible for making the motion happen, okay? Which seems like a lot of work, but it's not that complicated actually once you have the gist of it. And once you have this idea that there's this loop that you're going through, okay? So in order to show you this, I actually have some code that runs with a toolbox called MGL. So I'm going to try that first because I haven't really tried the site toolbox stuff. So I don't want stuff to break right from the start. I want to maybe break it in the second half so you can at least have a memory of things having worked. So in order to do this on your computers, what you can do is, let's make a script. Okay, so the caveat is this works on Macs and you have to download this toolbox. And then we're gonna go and do the site toolbox version in a second. But the logic is essentially the same, okay? You just need to think about it as in general terms rather than the specific commands that we're going to be talking about, okay? So, MGL script, explore stimulus display, and then down here we'll say use site toolbox to do the same. Okay, so I'm just going to save that as displaying visual stimuli. Okay, the first thing we need to do is we need to make sure that you all have this toolbox that I have installed here on the path. So let's start with MGL first, and then we'll do site toolbox second. So if I go back to the main window and go to set path, and I say add with subfolders, and now we need to go to this location on the network drive, which you will hopefully see on the left-hand side here. There's a shared computer called WSIG. So go there. Go to the folder called Practicals. DS1 are my initials, so you want to find that one. DS1, so small d and then an S at 1. And then we want to add MGL, okay, that folder. So Practicals, so let me make this bigger so everybody can see it. Practicals, DS1, MGL, okay. And then press open. And then we just say close, okay? Do you wish to save the current path for certain? No, but we could put it in our startup.m file, but you're not going to come back tomorrow, so it doesn't actually matter for now, so, okay? But if you're on a Mac at home, if you have access to one and you wanted to use this toolbox, you'd have to download it, put it in some place, and then use this. And we'll do it again, same in, oh, sorry, okay. So add set path again. So it's, if you go add with subfolders, WSIG, Practicals, DS1, and then MGL. Okay? I'll leave that up for a second so everybody can have it. Did it work okay for you? If one of those windows is a node, so actually, yeah. It was just one, so now it should work. Okay. All right. Okay, cool. So I'll just close this. So to know whether this has worked or not, if you type which and then MGL open, you should get an answer back, and it should point to the place that we just added to the path. Okay. Yep. Now, so that's good. So if that works for you, that's fine. So the way this toolbox is written, so Psych Toolbox is lovely and it's very powerful, but it gets very complicated very quickly. The point of this toolbox is that it was made to be sort of it's a minimalistic thing actually, right? So it started becoming a little bit bigger, but it sort of it strips down some of this giant functionality to sort of the bare essentials that people need. And so one of the nice things about it is that you can actually open up a little window that's only a small window, not the whole screen. So if you start a Psych Toolbox window and you make an error in your script, then you usually have a black screen and you can't go back to the MATLAB window. And you have to sort of type in the blind and hopefully you'll hit the right area of the screen and stuff. So there's ways to get around that, but it's sort of often what happens. If you just want to debug stuff, you can actually open a window with MGL open and call open window number 0, okay? Window number 0 means a small debug window on your screen, right? So if I hit Command and return, I get a little window here, but I can still sort of see around my desktop. So that's one of the reasons you can't see what, the stuff immediately behind it, obviously. But it still allows you to continue working with, whereas with Psych Toolbox, you'd have to now probably stop MATLAB and stop working, okay? Okay, so this is how you open one of those things. Screen number 1 would grab the whole screen, which I don't recommend. Screen number 2, MGL open 2, would open the next display that's connected. So that might be a projector in your fMRI scanner. Screen number 3 might be yet another display, and so on and so forth. Okay, so you're going to have multiple displays on here. Psych Toolbox does the same. If you want to close the window, clean up at the end, what do you think the command for that is called? If I made you guess, be MGL close, right?
What happens if you MGL open captures the entire thing?
Like I said, you shouldn't. Yeah. Then you just have to press. If you by accident forget to put the 0, not all is lost. You press Command, Alt, and Escape, which is the Control, Alt, Delete for the Mac. And then you have to restart MATLAB. No. He had a smile on his face. It's all good. It's all good. No, it's just funny because I was just saying how amazing it is that you can have this little debug window so you don't end up in a situation. So it's a good counterexample. So all right, cool. All right. So let's actually try something, right? So there's a whole bunch of functions that allow you to do things. So they all start with MGL. So MGL draw image, MGL, let's go with MGL draw, MGL, sorry, I just can't remember off the top of my head what they're all called. MGL. Points, polygon, MGL quad. Let's look at the help for MGL quad, which you give it some coordinates and it will draw them for you, okay? So let me just copy and paste this MGL quad line here. And paste it in, and then we can have a look at what that actually does. Oops. Paste. So actually, this might be a place for me to introduce. Has anybody ever seen what happens when you put 3 dots in a row? What that allows you to do in MATLAB? If you have a really long line, and you would like it to be shorter, you can put this ellipses, these 3 dots, and then jump into the next line, okay? So that means you can actually break up these big long lines. So let me just do that, because then it becomes a bit easier to see what's happening here, okay? And I'll put 3 ellipses here, okay? And then we'll do 1, 2, 3, okay? So first input argument, second input argument, third input argument, fourth input argument, okay? If I look back at the help for MGL quad, it says there's a vector of X points, a vector of Y points, RGB color, and whether I want to anti-alias or not, okay? So the way Eli, who wrote this function, decided to do it is you just need to specify the corners of this quadrangle by giving all the X values of the points first, and then all the Y values, okay? And so the reason you need all of them is because maybe you don't want to have one that's exactly a rectangle. Maybe you want to have one where sort of a slightly odd shape, and there could be all sorts of points, okay? So let me try and run this now, okay? So 1, 1, 1. What color is this in RGB? If all channels are full on, if 1 is the max, then it's white, right? So say I wanted to make it red, then it would just make the first one 1 and everything else 0. So if I do that, okay? So if I now execute this cell by hitting Command Return, where's my square? Where's my quad? It's, where is it? In the back. It's in the back office, right? Okay. So in order to get it to the front, I need to do MGL flush. Okay. So let me just make an extra line here. So, oops. So we don't execute the MGL open again. I'll see MGL flush. You can't see the tab completion. MGL flush. Okay. And I do it like this. Oh, actually, the first time you do this, this is going to be annoying. So this happens. Let me MGL close. Okay, then I need to do an MGL clear screen first. So let me just, sorry. So if your screen goes white, whose screen goes white? Okay, yeah. All right, so then that's a thing here. It crashed?
No, it flashed.
It flashed, okay. Clear screen. 0.5. Okay. If you, so the black square that stays up, that's one of the slightly more annoying recent things in MATLAB. If you press Command and the little tick mark next to your keyboard here, Let me show you where that is. Command here. Then it switches between windows, and when you do that, it disappears. The black window disappears. It's sort of, you force the screen to refresh. So back tick is just above your shift on the left. So if you press Command and the back tick. Okay? All right. So let me just double check so that this actually works. So if I clear screen and then draw. Okay, so actually it doesn't work because I need the screen coordinates as well. I'll just do one. I have a sample script that works, right? But I just wanted to build it up from the beginning. So, okay, there we go. All right, cool. All right, so I know what I forgot to tell you about. Okay, so in order to tell the drawing library whether we want to talk about our stimuli in pixels or in visual angle coordinates, we need to issue a command. So if you want to talk about stuff in pixels, then there's a command called mgl screen coordinates, and then everything you talk about in your stimuli after that point is going to be pixels on the screen. If you rather talk about stimuli in visual angle coordinates, then you can make one adjustment at the beginning where you issue a command instead here that's called mgl visual angle coordinates, and you just specify how big your screen is and how far away it is. And then from that point onwards, you can always talk about stimuli in visual angle. So that's actually really convenient. But I just didn't realize that the default was, you know, you set it to the wrong thing. So it basically would have, yeah, it didn't know what to do with those numbers. Okay. So if you put mgl clear screen, that makes the 0.5, that makes the screen in the back office gray, right? And makes rather, so we don't get this weird white effect because it doesn't know where to plot. If we then say whatever follows from now on is going to be in coordinates on the screen, right? So I want to talk about this point, which is at 100 pixels, and then 600, and then 600, and so on. And then you issue the command that actually does the drawing. Then this bit finishes drawing everything in the back office, and then mgl flush brings it to the front. Okay, and then you're done. Okay, so this is sort of the simplest possible thing you could do. And so now that you've seen me walk through this once, if you go and look in your code folder, there's visual change colors, which you can open up. Okay, so that's actually a function. And it does some funky stuff at the beginning. But now that you've seen the logic of the experiment, of that simple script that I talked you through, you can now see what's happening here. mgl open 0, open one of those windows, set the background to gray. Now we're going to go to visual angle coordinates, because actually usually I don't do in pixels, right? I don't do stuff in pixels. I always do it in degrees of visual angle. And in order to do that, you have to specify how far away is the display. So 57 centimeters is a very commonly used distance in vision science because it has some nice properties. And then 16 by 12 is a good guess of how big the window actually is on your screen. And then there's some stuff to do with if you're interested in colors, this will be kind of interesting to you. If you're like most people not interested in color, then you just can ignore it. Unless you know what cone contrast space is, this is not relevant. But then I just calculate some stuff, and I use an mgl command that draws little segments. And if you run this function, then you should get this. Okay? It's a static display. Okay? So this doesn't use a loop, right? It only does something once. Okay? So maybe you have an experiment where you just keep a static image up for 1 second, then this will be okay, right? Because you can just sort of, you can be done with it and then you move on to the next stimulus, okay? If you have dynamic stimuli, we're trying to draw something, okay? So I need to, so it's waiting for me to press a button, okay? And then it keeps this black window, so you need to do this backtick trick again. If you want to look inside the minimal move example, things now look a little bit different, okay? So I MGL open this screen. Once again, I set everything to visual angle coordinates. And now I've actually got a drawing loop, which is what you'll see in lots of the Psych Toolbox scripts as well, okay? So you basically say, for every time frame, right, how long is a frame? Well, however quickly your screen can refresh. So in most computers, it will be 60 times a second. But if you're interested in motion perception or something, maybe your screen goes at 100 or 120 hertz or something, or even faster. And you decide how many frames you want to display things for. So this is a for loop. And we do the same thing, but now this time we're doing it in the context of a loop, okay? Every time I have a new frame to display, I clear the screen, because otherwise it's going to start filling up, right, if I don't sweep it first. I decide on where the X and the Y values of my box are going to be. And so this bit in the front here is static, but you can see there's something that changes depending on which iteration of the frame we're in, which iteration of the loop we're in. So time frame is the thing that actually changes each time. And then we draw the quad in this location, and then we do the flipping, okay? So if you run this one, you get sort of a moving bar that moves in a sinusoidal trajectory, right? Waits for button press. So that thing is actually at the bottom of the screen. Sorry, I need to be in the command window actually for the button to be accepted, okay? And you can see down here, this is how you would draw some text in this MGL toolbox. Actually, if you run it, it will probably go, you know, it does the purr sound, the Mac purr sound, okay? And that's the general idea of creating stimuli, right? So if you have dots, a cloud of dots, then you have multiple objects for which you need to change the motion by updating the X position and the Y position on every frame. If you have a picture, then it's sort of the same idea. So there's also a script here that shows you how to display an image. So you could run that one. This allows you to pick a JPEG image, right? And there's sort of an extra step where you have to turn things into a texture first, which, so this probably looks a little bit, you know, complicated, but actually it follows the same pattern that I just explained. You just need to do something slightly different to the stimuli. And then the operation for putting something that you stored in an image beforehand is a little bit different, right? So you actually need to do something called blitting a texture to the screen. So let me run that one and see whether that runs, okay? So it asks me to pick a picture. So I have a photo I took a while back. Yeah, okay, so that would be how you display a picture for a certain amount of time. Okay, so, and obviously you probably don't just have one lemon, right? You maybe also have some oranges and apples or whatever, right? So there'll be other things going on there too. All right, okay. So now that you've seen that I can actually do it, let's switch to Psych Toolbox and see whether we can also make that thing happen, right? In Psych Toolbox. Any questions about the general idea of how this works, or? Oh.
In which case, can we pause for 1 minute? So
yep, absolutely. Yeah. Sorry, that's a good point. Yeah, there is. Yeah, let's do 5 minutes, right? Let's go.